Hello friend, this is Alok Sharma and you have rightly clicked channel Physicselevator. In this video, I will discuss a very important concept, that is discussion of motion of spring block system. We can study this motion from two frames. So in this video, I will discuss the motion of this spring block system in ground frame. Friends, before I begin this video, I would like to tell my location. I am in Palampur, India, in Himachal Pradesh state, and I would like to know location of my subscribers and fans, from which state you are looking this video. So kindly go to the comment box and write your locations so that I can get from where my video is being watched. So let us start. In this case, when problem is being looked from ground frame, means this is observer who is looking this all events. Observer is at ground. In first state, figure 1, there are two blocks having mass m and 2m connected with a spring, say spring constant some k. In this case, spring is at natural length and two impulses are given. 2v velocity is given to this block at this state, and v naught velocity is given in leftward to this block. So first I will analyze this situation. This is natural length and we can get location of center of mass. In this discussion, I will give many concepts to you. First, we can calculate location of center of mass. These blocks are at a separation L. L is natural length here. So first of all, we can calculate location of center of mass. What formula I am applying here? This formula is m1 x1. X1 is this location. This is location of first block, means x0, and location of second block is at x equals to L. So therefore formula is m1 x1 plus m2 x2 divided by m1 plus m2. Therefore I can get this information. It comes to 2L by 3. This is our location of center of mass. Now we can calculate velocity of center of mass, because in this case both the block will be moving as a system as a whole in this direction, and that velocity will be the velocity of center of mass, means system will move with the velocity of center of mass. Therefore I will use formula VCM, that is m1 v1. First block A is having mass 2m, velocity 2v, so this is m1 v1. Minus sign is due to opposite velocity of this block, otherwise in formula it is plus sign only, but minus will be taken due to its direction. Then m2 v2, therefore m and v naught divided by 3m. This will be the velocity of center of mass, and it comes out to be rightward in this direction. If I take this direction positive x, then in vector form I can be used here. Now I am going to a second figure. After this figure, when block are moving in opposite direction, spring force generates, because due to extension we are increase in length, this force will be there, and direction of spring force will be like this and this. Therefore velocity for this block decreases because force is in opposite direction. In the same way, velocity of this block also decreases because of this force is opposing the motion. Means after this event velocity decreases. So say velocity is VA and VB at any location, at any extension, then this velocity will be lesser than this 2v naught, and this velocity will be lesser than v naught. Means velocities are decreasing, this we can say. In figure 3, because this block is moving with initially velocity v naught, hence first this block will come to rest because this velocity is less, this velocity is more. So therefore velocity of this block B will become 0 first. In this case, this block is moving, means there is relative velocity of these two blocks. In this case also, this velocity is more, this velocity is less. Likewise, this velocity means block of having mass 2m is moving forward with velocity va, that is 3 by 2 v naught. That I will show you how we can calculate it. This block is moving, means there will be relative separation. So this increase in length continued because this block is momentarily come to rest. Force is in this direction, and this block is moving some velocity. So there will be further increase in the length. And how we can calculate this velocity? If this velocity is 0, then this velocity calculated by momentum conservation. So here in this part, momentum conservation is being used. Means this velocity, initial momentum in this case from figure 1, initial momentum will be P1 equals to m1 v1, yani 2m into 2 v naught minus m v naught. Therefore initial momentum is this. Final momentum in stage 3, or we can say in figure 3, momentum will be 2m va, say it is va, minus m v naught. So it would be like this. If I use momentum conservation from conservation of linear momentum, means this P3 must be P1, or this must be this value. Therefore 2mva can be written as 3m v naught. So from this equation, that is the equation of conservation of linear momentum, I can calculate this velocity. Va will be 3 by 2 v naught. Means at this time this block is moving with this velocity, and this block will be momentarily at that instant it will be at rest. So relative separation takes place. Means length of spring is increasing. Now what would be the next figure? Now in figure 4, velocity of both the block becomes equal at the time of maximum extension. Means at this moment we can consider that length is fixed, means momentarily there is no further separation between two blocks, hence there should not be any relative velocity. Therefore velocity of block A as well as block B will be equal to the center of mass. Means this point and the center of mass point will be moving with the same velocity, because if separation is not extending between the two particles, therefore all the particles will be moving with the velocity of center of mass. So at maximum extension, velocity Va, Vb and Vcm would be same, and it would be like this. This is the concept. So velocity is same. In this case, now compression begins. Means velocity for this block will be decreasing and velocity for this block will be increasing. Means velocity of block B is increasing and block A is decreasing. In ultimate case, in a final case, this velocity becomes 0. Due to this deceleration, velocity of block A becomes 0. And at this moment, velocity of block we can calculate by using conservation of linear momentum again. So we can apply linear momentum conservation. Since there is no external force in the system, hence linear momentum of system remains conserved for all the situations. Therefore initial momentum in this case we can calculate, it will be the same as that of figure 1. So it can be I tell it P4, therefore it would be 2m v naught plus both the velocity in same direction. Here I can write m v naught, all together it becomes 3m v naught. It is the same result as that of situation 1. Likewise, for calculating this velocity, when this block velocity of this block becomes 0, only this block is moving. So this is figure 5. I am telling it P5. It would be 2m into 0 plus m, say it is mass of v, only v is moving, and I can apply momentum conservation for P4 and P5 from conservation of linear momentum. P5 must be equal to P4, or we can say 3m v naught. Therefore this block B will be moving with velocity 3v naught. Only block B is moving with this velocity. Further to this situation, spring force will be in this direction, because now spring begins to compress, so spring force gets reversed. It would be like this. Hence, velocity of this block A will increase and velocity of this block will decrease, because compression takes place, so this velocity is getting released. In this situation, when it is 0, it would be this value, or I can say it is max value for this block B. Now, further to it, we can say again velocity becomes equal. Compression is taking place at the time of maximum compression. So, at maximum compression, here this block is at rest and this is moving, so compression is increasing, so there will be further compression, and in utmost case, when there is maximum compression of the spring, situation would be like this. In this case also, velocity of both the block will be common, and all three blocks will be moving with velocity v naught. That is velocity of center of mass also v naught. Means at the time of maximum compression or maximum extension, we can say there is no further, at that moment there is no further separation between two blocks. So we can consider just like a rigid body state here. So particle separation is not increasing, so velocity will be same. So this situation, in this situation, velocity of three velocities VA, VB and VCM would be the same. And further to it, again compression as well as extension takes place, and this process gets repeated. So motion of overall this ground observer, which is here, say, for this ground observer, motion will be in forward direction, system as a whole, as well as these both the block will be executing SHM about center of mass. So there would be compression, there would be elongation in the spring, and it will be coming to the natural length. So motion for this ground observer would be translatory with VCM velocity as well as SHM about center of mass. So friends, I think this motion of spring block system and ground frame would be clear to you in this video. And if you are liking such videos, and which will be very useful for JEE Mains, Advanced, and for other competitive exams also, so you kindly subscribe my channel and keep watching my video continuously, and share with them with others also, so that it would be beneficial to some more person who are in need of such videos. So friends, you have given your time for watching this video. Thank you. Thanks for watching.